today we're talking about solids, three-dimensional shapes. We're in section 9.1, and it's just identifying three-dimensional shapes and their parts. 3D solids and their parts. Okay, so some examples of three-dimensional solids are: you have a prism. Hopefully you've seen these before. These are like boxes. Okay, so we're just going to draw a rectangle. Then we're going to come back here and basically copy that. Uh-oh, what happened? We're going to come back here and copy that. I'm going to need to replace my battery. And then we're going to connect the corresponding vertices. And now we have a prism. Okay, so this prism right here, that's PRISM, is jumping around on me. This is a rectangular prism. Okay, so prisms are named by their base, named by the shape of their base. And prisms have two parallel bases. That's how you know that it's a prism and not something else. Okay, so another prism might be a triangular prism. Okay, so for a triangular prism, we would have a triangle here, we might have another triangle over here, and then we would connect them together. Okay, so it kind of looks like I call it a Boy Scout tin, or a Toblerone bar, if you like that German chocolate. You can do it with any shape that you want. We can also do pentagonal prisms. Maybe, if my pen will work, maybe not. Okay, so we might just have to, oh, there we go. It's freezing up on me. Sorry. Pentagonal prisms. Whatever the shape of the base is, then that's what you're going to use. Okay. So, let's talk about the pieces, though, those pieces of the prism. So if we take this rectangular prism that we have right here, there you can see it without the extras, and it just looks like a brick. Okay. Then you have faces and edges. Pretty much everything is a face. Faces are the flat surfaces. Edges, those are where the faces meet. Where the faces meet. Those are going to be at a line segment. Where the faces are going to be a plane. Okay, and then you also have the bases. These are the parallel faces that I talked about. Okay, the parallel faces. So a rectangular prism has many, many bases because you've got all kinds of rectangular sides that are across from each other. Okay, but let's say that I name this A, B, C, D, E, F, and G, right there. Okay, so an example of a face would be the flat piece. So you could have rectangle A, F, E, A, F, E, G. That's this front piece right here. That would be a face. Okay? Can you think of another face? How about the side on the right here? That would be another face. So that could be rectangle G, C. Oh, I have two C's. A, B, C. That would be D. Whoopsie. Sorry, guys. Right there. That should be a D. I apologize. So this would be G, C, D, E. Okay? Now, here's the cool thing. When you look at those two, We made those so that they touch each other. You can see that they're overlapping right here at that edge. That's GE. So where the faces meet, that's a line segment, I can trace that and it's green. So an example of an edge would be line segment GE. Okay. Another edge. Another edge would be line segment GC. And make sure you put that bar over the top to show that it's a line segment, not a line, not distance. It must have the bar over the top. Faces, those are parallel faces, so you always want to write these in pairs. Okay, so in this case, an example of your bases might be G, C, D, E, and so since that is over here on the right, okay, then we would need to pick its match that would be over here on the left. Well, we did not put the back in there, so I'm going to have to come up with yet another letter so we can name this corner right here. So let's see, we have G, we'll make that H, capital H. So then in pairs, G, C, D, E, and A, B, H, F, okay? A, B, H, F. And those would be our two bases. Now, could you come up with another pair? Certainly. Since these are rectangular prisms, you could go with the front right here and with back. That could be a base or a pair of bases. Let's see, we already did right and left. You could also do, I'll use yellow now, top and bottom. Okay, so those would have to be across from each other, and those would be examples of bases. Now, if I switched this shape and I made it, say, a pentagonal prism, like this. Okay, and I joined those top to top, side. I'm trying to make this as good as I can. There we go. Okay, so we'll make this A, B, C, D, E, F, G, H, I, J. So for here, there's only one option for your bases because their bases have to be the parallel faces. So the only option we have are the pentagons. Okay, those are the only options we have for our bases. So these bases would have to be A, B, C, D, E, and let's see, oh, that would be F. Sorry. Try to match it up so you have the corresponding parts together. So F, G, H, I, J. Again, it must come in a pair. It has to be a pair to name the bases. Okay, or that's what you're looking for as a pair. So all the other sides that are actually more rectangular, for instance, this right here, that's a rectangular part, that would be a face. And then some edges, you've got an edge right here where that face meets the base. So BC would be an edge, okay? All right, I hope that helps a little bit. So now, let's go ahead and look at some of the other ones. So let's see, all the different shapes that we have. So those are prisms. And then we have cylinders. Sorry, my pen's jumping around. So cylinders, here's an example of that. Basically, you draw two ovals. But for cylinders, the two parallel bases that are circles. They have to be circles in order to be a cylinder. Let's see, something else that we have. We have a pyramid. So a pyramid has one base connected to a single point called the vertex. Think Egypt. That place is full of pyramids. Okay, so you've got maybe a rectangle down here, and then you've got a point way up here at the top. That would be your vertex. It sits above it, and then it's just connected to all of those other corners. Okay? And that would be your pyramid. Those can come in a variety of shapes too. You can have a triangular base if you want to, and maybe it's right there. So we've got the one in the back and then these two. Okay? So this would be a rectangular pyramid because the base is a rectangle. Okay, there's our rectangle. It looks like a parallelogram, but you kind of have to understand that it is a rectangle when you look at it because it's in perspective view. And then this one has a base that's a triangle, so this would be a triangular pyramid. Okay. Really, I think there's only two other shapes. I mean, you can have a variety of pyramids as well. It doesn't matter how many different bases you have. You can have an octagonal pyramid with a base that has 8 sides. Okay, so just keep that in mind. But you always name it based on what the shape of the base is. And then we also have what is called a cone. Think ice cream. Yes, it looks the same. Ice cream cone, you kind of just have that V shape, and then you've got a circle there at the top or bottom. You can also turn it this way. You can turn it sideways. It really doesn't matter. Okay, so we could do this, and we could have it like that. So cones can look a variety of ways. And then we also have a sphere. Okay, and that's just a ball. We usually kind of do this to show that it's 3-dimensional. So that's your sphere. And it's just a ball. And then I can really come up with a definition off the top of my head. Okay, so a sphere is going to have no faces or bases because it doesn't have any straight sides. Okay, a cone, the base of a cone is going to be a circle every time, and then it's connected to a vertex. So we have our circle right here, we have our vertex up at the top, and we just connect that vertex to that circle, and that's how those cones are formed. Okay, so I think that's about it for the actual different solids and what their parts are. When you come back to class, we'll fix any confusion that you have with those, and we'll get going on surface area and volume. Thank you.